Hello, my name is Massillia RADI, a doctorate degree student in green chemistry at the University of Oran Ahmed bin Bella. I am honored to present my research entitled Synthesis and Characterization of a Semi-Conductive Copolymer Doped with Iron Chloride. The aim of my research was to synthesize a new semiconducting copolymer based on the polycondensation of a bio-based monomer, which is cinnamaldehyde, with thiophene catalyzed by sulfuric acid. The polycondensation was carried out at room temperature for 24 hours using chloroform as the solvent, and the yield of the reaction was approximately 65%. The copolymer obtained was subsequently doped by an iron chloride solution for 24 hours. Infrared spectroscopy and UV visible were used to characterize the copolymers prepared, and the electrical conductivity was determined using the 4-point probe method. Electrically conductive polymers are macromolecules with charge transport properties, characterized by the presence of a p-conjugated system on their main chain. The polymer alone is not as conductive. In fact, conductivity only appears with the introduction of dopants, chemical species bound to the polymer inducing an excess of charge on the chain, thus ensuring interchain conductivity. Among electrically conductive polymers, polythiophene and its derivatives have received considerable attention owing to their high electrical conductivity, good environmental stability, and relative ease of synthesis. However, their practical use is limited because of their fragile structure and insolubility, which leads to processing difficulties. Copolymerization could be a desirable route, as chemical bonding between a new monomer and a conjugated polymer can improve the chemical stability of the polymer. We have therefore suggested to copolymerize thiophene with cinnamaldehyde using sulfuric acid as the catalyst in the presence of chloroform as the solvent. So the copolymer obtained was subsequently projected to doping using an iron chloride solution. According to the infrared spectra illustrated in Figure 1, both doped and undoped copolymers exhibit an absorption band at 1681 cm-1, which is characteristic band of the double bond carbon, proving that both copolymers has p-conjugated structure and confirm the success of the synthesis process. For the doped polymer, a new absorption band appeared at 573 cm-1, which can be assigned to the formation of a complex between iron chloride and the semiconducting copolymer. As for the UV visible of the copolymers, shows a higher absorption intensity for the doped copolymer in comparison with the undoped one. Both copolymers exhibit two main absorption bands. The first is in the range of 200 and 300 nanometers, which can be assigned to the P transition, and the second one in the range of 400 and 450 nanometers, which can be assigned to the band gap transition. The electrical conductivity measurement of both copolymers showed that doping polycinnamaldehyde cothiophene with iron chloride induced a significant improvement of the electrical conductivity. To conclude, we can say that we have successfully synthesized a new conducting copolymer using the polycondensation of cinnamaldehyde with thiophene in the presence of sulfuric acid as the catalyst. The effect of iron chloride doping was studied, and the results showed a good enhancement in the electrical conductivity of the copolymer doped in comparison with the undoped one. Finally, I have to say that the present research is not complete yet. Other analysis techniques should be performed to identify the chemical physical properties of both copolymers. Thank you for your attention.